Hello everyone, this is Ram Nivas from Department of Electronics and Communication Engineering. In today's class, we will see about the logical operator. We all know that logical operators are and, or, and not. In addition to that, we'll also see the implies and equal to. And their technical names are conjunction, disjunction, negation, and equivalence. The conjunction, e- disjunction, implication, and equivalence will have two operands, and negation will have only one operand. And their usage is also listed like this: P and Q, P or Q, P implies Q, P equal to Q, and not Q. Not Q is nothing but negation. So conjunction and disjunction, if one of the input is false or both the inputs are false, then your output will be false. That is simple AND operation. If two inputs are enabled, then your outputs will be enabled. In case of disjunction, if any one of the input is true, your output will be true. If both the inputs are false, then your output will be false. If both inputs are true, then your output will be true. Next is implication, equivalence, and negation. In case of negation, if input is false, your output will be true. If your input is true, and your output will be false. In case of implication, if one input is true and the other input is false, then your output will be false. Rest all the conditions will be true. If your one input is false and other is true, false, false, and true, true, the condition will be true only. The only implication is one condition: first input is true and the second input is false, then it is uh, false. If it rains, the ground will get wet. Okay, this is the example for implication. In case of equivalence, two inputs should be same. For example, false and false can be true, true and true can be true, but true and false cannot be true, it is false. Okay. And types of logics, one is propositional logic, next is predicate logic. Propositional logic is it focus on proposition and how they combine using logical operator. If it rains, I'll take an umbrella. Okay, so this is propositional logic, and this can be also called as sentential logic. Okay, and predicate logic is also called as first order logic. It extends propositional logic by including quantifiers and predicates that can express relationship about the objects. So the example for this is all humans are mortal. Okay, this is a universal truth. No one can be immortal. And logical connectors, so these are how you'll use them in any programs or logical indications. And operator, you'll have this symbol of cap, or will have the symbol of v. Not or negation will have this negation symbol. Implication will have an arrow mark. Biconditional will have a double pointing arrow mark. So these are how you're using it. So if it is negation, it is raining means, then it is meaning have the meaning of it is not raining. So true and false are indications in conjunction and disjunction in and or operators. So this is how the example of using them. So q and r is false, both are false. So if you are applying all or operation, your output will be false. Not of or, not of previous case, so false is converted to true. So true, p and not of qr, you'll get true and false combination, you'll get false only. If two conditions are true, then only you'll get true. Okay, so in the fifth line you can see, okay, and the condition is true and p is also true, finally you're getting the true output. So these are the symbolic representation. Negation of a, you'll get false, false, true, true. A and b, you'll get t, f, f, f. A or b, you'll get t, 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 f. And reasoning, there are different types of reasoning like deductive reasoning and inductive reasoning. Deductive reasoning is that all humans are mortal. Socrates is a human, therefore he is mortal. It moves on general premises to a specific conclusion. Uh, if the premises are true, the conclusion is guaranteed to be true. So that's the reason. All humans are mortal. Socrates was also a human being, so he is a mortal. Inductive reasoning moves from specific observation to broader generalization. It is a probabilistic rather than certain. Sun has risen every day so far, so it will rise tomorrow also. So this is a hope that sun will rise tomorrow. So evaluating proposition to logical equivalent. Two propositions are said to be equivalent if they have the same truth table. Okay, so like not of P and Q and not P or not Q will give the two same results. Okay, so when you are performing P and Q and doing the not, as well as you are not P and not Q and you are ORing them, so this both will gives the same result. So whatever you are doing the interchanging operations in between, and the final results will be similar. And evaluating proposition, you have this tautology and contradiction. It is a proposition that always true regardless of truth values of component proposition. Contradiction is a proposition that is always false regardless of truth values of its component position. In terms of electronics, we will say this concept similar to that of false, that are stuck at false. It is always stuck at 1 and it is always stuck at 0. So applications of logic in mathematics for proving theorem and solving problems. So if you are working on correct logics, you will get the correct results. In case of computer science, you are designing algorithms and digital circuits. In case of philosophy, you are analyzing philosophical arguments. In case of artificial intelligence, logical reasons are done for decision making systems. Thank you.